Okay guys, no issues. Is this visible? Am I audible? And is this visible? Yes, yes, yes. And we'll check for the missing values. So for each and every row, column, sorry, we are getting passenger ID have. Passenger ID have 0, survived 0, P class 0, null missing values or null values. Age having 117 null values. Cabin has 687 null values. Embarked have 2, right? So okay, this is fine. We got the basics understanding of how our data is looking like. So if you want to do statistical analysis, then at that time we use df.describe, and mostly I use .t to get it transposed such that to easy for understanding. Like this is the column name on the left side, and this is the count mean standard deviation 25. So you can see that passenger ID mean is 446, survived mean is 0.3, age, so mean of age people have is 29.69, like 30 years old. So what is the fare? Fare is nearby 32. I don't know, $1,000 or $32. So guys, okay, sorry. Let's continue. So once we're done with this, we'll try to do EDA part. So basically, we'll put over here EDA. EDA is nothing but exploratory data analysis. So what we are trying to see, okay, we'll check for the how many people will survive. So how many people will survive? So df.survive.value count. If you do this, you are getting 0 and 1, right? And if you want to do it like more visually, just we'll try to plot a figure, plot.figure. And what we are plotting, we are plotting about the, we pass the figure size first, so that is fine. So we will try to plot, count plot, and for what? For the data. Why this is happening? Yes. SNS.countplot, it will give you a count plot related to 1. See, this is univariate analysis. I'm talking about univariate. Are you guys understanding what I'm doing? Or am I a little bit fast? If I'm fast, let me know. If you want me... Oh my god. See guys, see this? Okay, leave. It doesn't matter to me. Okay. So, just a second. हाँ भाई. Hello. Hello. So this is univariate. Hello. हेलो. हाँ, मैं अभी क्लास ले रहा हूँ, मैं करता हूँ तेरे को. कुछ इम्पोर्टेंट है क्या? ठीक, ओके. Is this visible guys? Sorry, I got a call. First question, am I going little bit fast? You want me to little bit slow, like to do this little bit slow? If it is fine, put a thumbs up guys. The pace is fine, then I'll continue with this. Yeah. So whatever 0 is 549 and 1 is 342. So instead of doing this also, you can plot it also. Okay, how it is looking like. Similarly, you can do for the class based also. See, we are having one P class, right? Passenger class. Then you can do for multivariate analysis. You can do like one survive with P class, survive with name, survive with your gender, survive with age, survive with sibling, spouse, whatever there is, right? So you can do it. It doesn't depend too much. So we'll do for one more. We'll do with the gender one. Okay. So we'll plot SNS dot count plot again, because we are counting something. Count plot for P class. No, I'm not talking about P class. I'm talking about the gender one. So in the first parameter, I'll pass the gender, that is sex over here. And over here, if I want to check if they are survived, so I have to use hue as survived. So yeah, data frame is df and palette is set1. It's fine. Right. Is this fine, guys? Similarly, if you want to do for age or something, just put for age we use hist plot and we'll pass age. Yeah, same thing we got. This is what we are getting. KD is nothing but kernel density estimation plot. So this is the estimation plot, KD plot. Fine. Okay. Is it fine, guys? How many of you got till here? Like, how many of you reached here? Raise your hand if you didn't reach till here. Raise your hand if you have not come till here. Else I can ask anybody to share their screen live, right? So if Thanos, any issue, brother? Apart from Thanos, anybody else having problem? Bro, any issue? Thanos, BR Adya. No issue. So why are you not doing, bro? Okay. I was saying in mobile. Okay, it's fine. At the end, I'll share the link of it, but still. Okay, once we are done with visualization part, we don't need too much visualization because our prime goal is to train a machine learning model over here. So we'll go with the cleaning part, data pre-processing part, whatever you call data pre-processing. CESSI is data pre-processing. So in that data pre-processing, what we'll be doing, we'll be removing irrelevant features, whatever we don't need, or we will be filling the null values. For if it is a numerical feature, we'll fill with mean. If it is a categorical feature, we'll fill with if it is a categorical feature, we want to fill null value mode. Yes.
We'll do the encoding part of it.
Encoding part is also needed. So either you can do by, okay. Tell me one thing. Naive Bayes was क्या कहते prone to encoding or not? Like scaling part. First of all, tell me, is Naive Bayes prone to scaling part? Yes or no? Hey, who are these guys here? They are coming randomly, right? Leave. Is Naive Bayes prone to scaling, feature scaling? Yes or no, guys? At least use ChatGPT and answer.
No, it's not. It doesn't need feature scaling.
And SVM, support vector machine?
Yeah, it needs it.
Correct. So it doesn't need feature scaling. So what features we have, we can put it directly over there. But if you want to do scaling also to make it more accurate, we will try both of the features if we have time, right? So let's do with the basic part. We will be cleaning first, then we'll be removing the irrelevant features. That is the cleaning. Then we'll be filling the the क्या कहते हैं numerical features. So first start with the dropping part. Dropping column that are not useful for prediction. Yes. Passenger ID, name, ticket, cabin. Let's check first. Passenger ID survived is important. P class is not important. You can take it or you can remove it also. Name not important. Gender important. Age important. Sibling, spouse, you can drop it also, you can have it also. So let's have it. Park, I don't know what is park, by the way. Park number of parent child. Okay, parent and child. We'll take this also. Ticket, what is ticket? The ticket number, that is not important. Definitely it's not important. Fare, not important. Fare, passenger fare. And cabin kb number is important, but we don't have too much of the value, so definitely I'll drop it only. And embark, I think it is an object, so okay, still fine. We'll have to do encoding part for embark. What is embark? Port of embarkation, where they have, okay, Cherbourg, Queenstown, Southampton. Okay, fine. Okay, so we are dropping passenger ID, name, access in place equal to 2. Before that, I want to check for the columns name. So now I can match it easily. Passenger ID, yeah, definitely I'm removing. Name, survive, T class important. Name removing. Age, sibling, spouse, parent, child important. Ticket fare doesn't matter. I'm removing is correct. Fare is not important. Should we take fare, guys? Hello. Hello.
We can keep it.
We can keep also, right? But how many of you want to keep fare in the model prediction part? Put a thumbs up if you want to take. Put a thumbs down to remove it. Thumbs down are more. Vaibhav, better luck next time, brother. Okay. So we will drop fare. Why not we decide using the heat map? Let's try using heat map now. We'll plot heat map. For that, just I'm passing data is equal to data. Then what is next? Data frame is given VM, not needed right now. Annotate, yes, I need to be annotate. So annotate is equal to true. Format CMap line width fine. Line width is not important. We haven't discussed about this. So just name data. Data is df. Could not convert string. Oh shit. Data is equal to df dot select data. Select data types. In that I have to pass include float and integer. That's it. And then we have to plot. Or in fact, of float and all, you can put number also. I think so. Yeah, fine. So in fact you can use both of them, and I want the figure size, so I have to change the figure size. plt dot figure size 10 by 6 instead of 10 by 6. Let's increase because 10 by 18 right, or 12 by 80. Oh, 12 by 80. See, we are having some issues, no? See, over here we are getting numbers, and over here we are getting this. So let it include numbers, but okay. So first we will do this, no? Fare we need or not. So to check this, we'll try to plot heat map. So basically we will plot heat map. No issues. What is the issue over here? Data df dot select data types include number on. Okay. So we'll do one thing. We'll check df के अंदर जो ये अपना पहला चीज़ है, that is fare. Df dot fare. It's first of all float, no, integer. Then kbin and this. df dot fill, no. What I want to do, उसे क्या कहते हैं, label encoding. So we'll be performing label encoding for categorical values, but before that we'll check how many categorical values are there. So I am putting one more cell. So df dot kbin dot n unique, pass this. So 147 unique values are there. We should drop kbin, no? Let's drop it. because 147 unique, if you try to do mapping and all, no value you are getting, like it's too bad. Then what is embugged? Embugged is of 3 types, so yes. So till now I am dropping this also. Let's drop it. Now let's do the df.info again. In that we are discussing about fair, no? This embugged. Okay. We'll try to use categorical values. Okay, it's from sklearn. We import label encoder correct, and for whatever the data set we want, object in columns, fit transform, live fit transform, df.column, df. Yeah, correct. It's fine. Done. So what will happen now, if for the embargo now, it will be 1 2 3. If you check, if you put df.head now, df.head, let's do this embargo on df.embark dot value count. So you can see 0 1 2 3, like it is having 0 1 2 4 different columns, and they have given marked as. Earlier it would be, if you do over here, somewhere here, df.embark dot value counts, and I'm running on. See, we are having SCQ, right? And some of them are null values also, I think so. So for the null values, okay, remove this. See, embarked is having this, right? And after the after the categorical conversion, you can see for the null values it is giving another data type, that is 3 or 4 2, right? So before doing pre-processing, you should drop null values. One more key concept you should understand: before doing label encoding, you should drop null values before encoding, else null values will be also encoded as another category, right? So we should drop null values over here, df.drop, or fill, because it's 2, we'll fill na with the method that is here. Fill na what? Age, just a second guys, age having 714, right? Okay, so it was fine on. And mode, complete the bracket, comma in place is equal to true, because we want it to be reflected in our data frame. So we should run it on. So how many, yeah, see over here, everything is now in null free. Second part is we are having data type as object. So what is the error over here? Not supported between instance of method and string. Okay, let me check the df.embark. What is value counts? SCQ. So there is one more thing. Without using label encoding, you can directly map it also. We call it as mapping function. So if you want to use mapping function also, you can use mapping function. In that mapping function, what we do, we particularly from our side, like over here, no, we are giving this data, that object data, to the label encoder. Okay, bhaiya, you just encode by yourself. But if you want to use mapping by your own, okay, I want to map 0 to 1. So you can use it into categorical data also. Data, yes. So to map this label encoding, I didn't know why it is giving error, but not supported with instances of method and string. Okay, no issues. What we have data frame, in from that we are having embark. No, we don't need this. df.embark.map function, we'll use map function. Yeah, c0 and 2. Now fine, we got this. And if you do now this क्या कहते हैं value count, so we are having 1, 2 and 0, 3 categories like this. Now let's try plotting heat map, and we should not use this now, we should use df. Okay, age is a object. Oh, shit. Okay, same we will can map it for the gender also. So that is sex over here. So how many categories we have? df.sex dot value count, male and female, just use male over here, map male as 0 and female as 1. Now run on. I'm not getting why this is giving error, but okay, just a second, I'll check. I give correlation, annotate, relation is what heat map. Correlation is nothing but data. Okay. There is one more way of doing correlation. We will define correlation is nothing but df dot correlation with what? The numeric data type. So that is fine. And this will use, yes, and I will remove this. Yeah, we got the heat map of for R, and this is too big. We'll use 10 by 8. This is our heat map, right guys? So over here, if we are checking ki survived and fair, it is positively correlated with 0.26, right? So that's why we will not drop it, right? And negatively correlated of this parts is less correlated with survived. Is it correlated with something? Yeah, sibling and spouse. That is parent and children, sibling and spouse, highly correlated. Fine. Apart from that, fair, embarked. So if you want to drop parts, you can drop it. If you want to drop sibling also, sibling and spouse column, you can drop it. Yes, you can easily drop it. But let's go without dropping it. Let's see what, whenever we are giving our model, how much accuracy it is giving. If it is giving less, we will do one thing. We'll just change it to क्या कहते हैं उसको. I will drop these columns, right guys? Are you guys getting what I am doing? Which column did I drop? These are the column, brother. Right now I am having 7 columns. Earlier it was having 11 columns. Like 4, I dropped the 4 are passenger, ID, name, ticket, cabin. This 4 I am dropping. Right, now we will check for df.info. Right now I did no df.info. Yeah. So 889, embarked is still having 2 null values. So okay, df.fill and for what everything. Age is filled, right? So we are having over here for embarked, right? So embarked was 0, 1, 2. So you can put anything in place is equal to true. That is doesn't matter actually. Embarked is the boarding station, no, where they have giving. So you can use this also. No issues. That is not gonna make a huge difference. So 891, 891, 891. Now fine. Now what else, guys? After this we have done. We have been dropped the 11 feature. We filled the missing values with the mean also. Where we have done this over here. For the age, we put it mean, and for the embark, we put it the mode, but I don't think so it worked. But okay, it's fine, no issues. df embark dot mode. Okay, in place is equal to 2. Filling missing embark with mode we did. Apart from that, if we want to check is there any null values again, you can check it again. But right now it is already cleared, so I am not explicitly checking. But to check, we can put simple a command df dot is null dot sum. df dot is null, this one. It's a function, so no null values are there. So apart from that, now we can go for the training part. Right. So we will do the splitting of our data set, and we will be just training it, basically just normal training, right? So what are the features we are having? Features we are having is survive, definitely we want. P class we want. Age, gender, yes, age, sibling, spouse, parent, child, fair, embarked, right? So what, okay, done, no issues. So we'll tell one thing. We'll use df.survive and y is equal to df survive. Why this one? Because I'm now splitting my data set. For x, everything apart from survive, like all this, and one data set with only survive, this y column, right? Are you guys getting what I'm trying to do? Splitting one data set into two parts where I am having category, all the depending category. These are the independent categories, and based on that, he survived or not, or she survived or not is dependent, right? So I'm taking this in one data frame, and based on that, I'll be plotting the relation with the another this survived. Are you guys getting? Or else I have to join my notebook to share. Okay, give me a second. Just a second. I'll show it visually because it's in my mind what I'm trying to say. Okay. Okay, what I'm trying to say over here कि ये अपना data frame, this is our data frame, right? This is our data frame. In that, these are the columns, right? So out of the 7 column, what I'm doing, कि I am giving this as x data frame, and I am mentioning this as y data frame, this last column, with all the rows, with all the values as y, and this all columns and the rows with the value x. Now what I'll do, I'll tell model कि based on this x, this is the y, how it happened. Means कि ये pattern है. If this is the case, this is the y result, what y is. That did he survive or not based on this x. Based on this x, I'm telling again and again. Based on this x, did he survive, yes or no, 0 or 1. And the model will learn, and what I'll do, I'll split the data. Let's say splitting means कि this is your full data, right? This is your full data, 100% of your data. I'll tell model कि 80% of data will be getting to the train, this data, 80%. Are you guys getting what is 80%? This data is 80%. Will be given to train, right? Then model will try to test what he has learned on this x part, x train part. This is x test part, sorry. This is x train part. Same for over here. This is y train part. Y train is known for the model to learn. This is y train. Y train, this is x train. For x train, whatever the parameters are there, whatever the values are there, this will be given to the model, and also the y value. Okay, on behalf of this characteristics are present, then he survived. And for this characteristics, he didn't survive. And model will try to find a pattern, and as the model find the pattern, now what's the next? We will give model this unseen data. This is unseen data. This part is unseen. That was splitting means 80% of the above data and 20% of the below data. 20% are unseen, 80% are seen. These are seen data, these are unseen data. And model will try to predict the y of this y over here, the left part. Based on this, we will find accuracy and everything, right guys? Are you guys getting me? Okay, what is x train, what is y train, what is x test, what is y test? Did you guys got the concept? X train, Y train, X test, Y test. Jayesh is coming and going. Nice. Okay, guys. So this was the basic thing. Just a second. I keep my tablet side. Okay. So we have dropped for X. We have dropped like similarly. We have dropped the last column. That is the survive column. We have dropped. And for Y, we just selected survive. We just select only survive. Only survive column is selected as target variable. Okay. Right? Now, basically, let's go with the X train and Y train. So for X train, X train, X test, Y train, Y test. That 4 parameters what we have just discussed now. X train, X test, X train, X test, Y train, Y test. The 4 splitting will be done by train test split, which we import by sklearn.models. Something is there. Splitting update, model selection. From that, import train test split. Right? And we give XY test size. What is your test size? 0.2 means test size. Means this is 80%, right? This is 20%. If you remove the percent, it will become 0.20. Over here, it will be 0, right? 0.20. And this will be 0.8. So test size we have to specify. Test size is 20%. Random state to store the particular selection of the data, right? Now if you put, no, this is not complete yet, because we need to tell the model what we want. We want to select a model, right? After this selection, the splitting is done, we will train the model. So we'll select the model. What is our model? Gaussian naive Bayes. So we selected, we'll try to tell model, okay, this is X train, this is the train data, this one, X train data, this blue one, sorry, X train data, and this is Y train data. Learn both of the data, find the correlation, that is fit. Find a pattern between this. You can see fit Gaussian neighbors according to X and Y. And based on that, we'll then pass only X test, such that we will give to predict the X test value. Okay, now predict this X test value. Okay, what will be the output for this, as you have learned from X train and Y train. Are you guys getting? I am just doing a lot. Yeah, okay, fine. So then we'll tell it to predict. So predict karenge hum. So if we want to predict, where predict is nothing but Y predicted, what it is predicting, and what is actually Y test. No, this is the actual data, how it is. Actual data, this whole red giant is the actual Y test. And now what is Y prediction? What the model has predicted, that we will store in Y prediction, and we will just compare with the actual Y test, such that to get the model accuracy and model performance. So right now I'm not doing evaluation, I'll do evaluation in the next line. So model is trained, my model is trained on the Gaussian naive Bayes. Gaussian naive Bayes model is not trained on the X train and Y train, and we have given X test, and it is also predicted now. Now we want to evaluation. We want to do evaluate the model. For the accuracy, we will put accuracy score a function where there Y test and Y prediction. What is Y test? What is the actual Y test value, and how it has predicted? That is Y test and Y predicted, right? Then we want to print the accuracy score. Sorry, it came, I just started doing. Print accuracy, whatever the accuracy, multiplied by 100 if you want to in percentage something. Okay, so it's fine right now. So accuracy, we got 77% accuracy. Are you guys understanding how it is working? Do you guys understand? Yes. Okay, we got 77% accuracy. Now we'll do just basic confusion matrix. We'll try to plot that true, negative, true, positive, false, negative. So confusion matrix is nothing but confusion matrix, Y predicts, print confusion matrix. So this is confusion matrix, but if we want little bit hi-fi, so we'll use sns.countplot. We'll use sns.heatmap. And here we'll be passing the what we have confusion matrix. We'll put annotate is equal to true, and what it is not survive. Okay. See, we got our confusion matrix. Not survive, survived. Survived and survived, like our model have predicted survived as survived is 15, but the person is survived, but he is predicting not survived at 17. He didn't survive, but predicting as survived is 23. Are you guys getting? for more better, I should do one more thing. I should put plot label is this and x is this is predicted one. Predicted survive, predicted not survive. The left side, the x-axis, sorry, y-axis is actual data. Now I think so it should be clear. Or you can do one more thing. For classification report, I'll give a report is equal to classification report, y test y prediction, print classification. This is precision recall F1 score and support. Okay. So we are getting accuracy of 78%. Are you guys getting what we just did? Now do one more thing. Let's try to play with it. Now we'll do engineering stuff. See guys, now we'll select only the columns which are totally dependent upon survived. P class, yes, we'll drop this. What is this? Age is not totally dependent upon survived, but it is dependent upon P class. So we'll take age and this sibling spouse and parent child. Let's remove this off too. I'm just playing. Okay, so I'll over here only I will drop, but again I'll add over here. Where is dropping part? Sibling spouse. Sib SP. What is this? See, now there is a high chance that our model will become overfit. Reason being, we are giving less features, but let's see. You can't predict everything. Not found, it's fine, no issues. See, we got again 78.78% accuracy. Again, same thing. So we notice one thing, like having those feature is not putting too much effect into the model accuracy, right? So if we try to drop it, so it didn't made a huge impact. Meanwhile, you can check for age and impact. See, if I remove this and I'll just give pass only one age, and now if I run off, sorry, again the same result, we got 77.65. So the point is ki how you can make the values more better. Sub basic question, the basic understanding question. Now we have dropped name, we have dropped, okay, we'll do over here on df.head. Or put df on it. We are getting some fair as fair df.fair and farewell. If you want just fair column, see, these are the values, somewhere 53, somewhere 71, somewhere 7, somewhere 13. So if you want to do skewness for this, you can do make it skewed, like kya kehte usko, scale. If you want to do scaling for it, you can do scaling. For that, you have to import that min-max scaler. So from sklearn, what I'm doing, I'm just doing a scaling part. We're using min-max scaler, just min-max scaler. You can use that another one also. So from sklearn, so oh sorry, it came, I didn't notice, I just started from min-max scaler min-max, whatever we want, we'll put x. Now fine. One thing I have to do now, I have to just pass, you can pass x also directly, no issues. And again you can train the model on that x only. So we'll put it over here. Let's check how scaling affects our model. So it didn't created a huge impact, that is 0.78 still. Okay guys, so this is what we are getting, but we did scale, no, but still fair. That means it didn't work properly. I should change the names. And what is x over here? Oh shit. So for if you are training with X scale data, how much accuracy we are getting? 77.65. I think so. That is the same one, but it should not be same. So X drop survived. Before that, we should check how is X scaled over here. That is getting scaled. And why? Getting trained. Fine. That means we are getting the same accuracy, 77.65. So that means scaling over here doesn't create a huge impact, right guys? So we got 78% accuracy. If you want to improve accuracy, now what we can do next? Let's think something. What we can do?
They can do feature engineering.
Sorry?
They can do feature engineering. We can make
That's what I was also thinking. And let's do one more thing. I wanted to tease this also. Now let's run on. It's still the same. Let's remove this scaling part. Yeah, you guys can do this feature engineering. You just add both of them, siblings, parent, child is alone, something was there we were doing. So you can try that doing also. Yes, if you just try using different, for example, we dropped cabin, right? Remove dropping age. Oh, nice Amitav, nice. I changed median and I dropped the column over here. Nice. Run on. 77.65. Let's change this back to mean. Run on. $77.65. Why so? क्या पास हो रहा है मॉडल ट्रेनिंग में? एक्सटेंड पास हो रहा है, एक्सटेंड वाई सर्वर एक्स इज इक्वल टू 1. Okay, see guys, if you want to do, you can do feature engineering also and try doing it, and if you come up with a better accuracy, just let me know. Then I'll also try to beat your accuracy. Like, I'm not challenging, but if you find something other way, it's better. See, right now I told you, we are just working on project and we are not targeting the accuracy part. For the particular project, if you are targeting accuracy, at that time there are multiple things what you can do. Multiple like sibling, spouse, parent, child, how these are giving. For the ticket, you can do encoding for the ticket also. But if it is important, fair, is it important? So you have to check for that particular importance of that column, right? So for that, if you can do one more thing, you can try box plotting, and for that particular importance of a column with a survived one, you just have to check for the heat map. For the both feature selection, if you, this is known as feature selection. If you are selecting some of the features from all features, is known as feature selection, right? So this was the today's class. If you have any doubt, you can tell. Else done and done.